Recording in progress.
Yeah, good evening. See, you're learning collections framework. Collections framework. Collections framework classes and interfaces in which package? Java.util package. Java.util package classes and interfaces. How many categories divided? 2 categories. First one, collections framework collections. Second one, legacy collections. Collections framework collections, how many subcategories divided? 3. What are those? Core collection interfaces, general purpose implementations, more utility collections. Okay. Core collection interfaces, first subcategory I given. Okay. How many interfaces are there? 10. What are those? First one, collection. Second one, list. Third one, set. Fourth one, map. Fifth one, sorted set. Sixth one, sorted map. Seventh one, navigable set. Eighth, navigable map. Ninth, queue. 10, it is just a deck only you have to call. One more U is there, DQ. Say it is double-ended queue. It is actually short form. D means double, E means ended, QUE means Q-like, double-ended queue. I'll give. These are comes under core collection interfaces. These are core collection interfaces. These interfaces are the foundation of collections framework. See, core collection interfaces. These interfaces are the foundation of collections framework. 10 interfaces are there. Collection, list, set, map, sorted set, sorted map, navigable set, navigable map, queue, deck. Okay. This is complete documentation available. Like each and every package documentation available. See, if you open google.com in this java.util package, if you type, see, you'll get it here. Docs Oracle Help Center. Here, see, interfaces in util package. How many are there? See, many are there. No? Classes. See, how many classes, how many interfaces you observe. Enumeration, it comes further. Exceptions, errors. See, these many in java.util package only, these many. So one package. Okay. Like suppose collection interface. See the description. The root interface in collections hierarchy. So like this description available here. Suppose list. See, list. An ordered collection, also known as sequence. Okay. Like a set. See, a collection that contain no duplicate elements. Like everything, description also available. So you can click more depth. See, more depth about list. Which version released also will be there. See, methods. That is everything documentation available. Okay. Here, core collection interfaces. These interfaces are the foundation of collections framework. It is very basic. So core, basic. In a collections framework, it is basic. Now, these all interfaces. Each word first letter is capital and no space between words. Now, one by one, we'll see. First one, collection interface. Collection interface. It is a root interface in collections hierarchy. It is a root interface in collections hierarchy. It is a root interface in collections hierarchy. Core collection interfaces. These interfaces are the foundation of collections framework. Basics. 10 interfaces are there. First interface, collection interface. So interface name only collection. Interface name only collection. It is a root interface. Otherwise, you write like this. It is a root interface in one-dimensional collections hierarchy. One-dimensional collections hierarchy. Because one-dimensional, two-dimensional is there. It is a root interface in a one-dimensional collections hierarchy. So at the top of the hierarchy, this interface will be there. That is root. For example, which class is superclass in the entire Java library? Object. Object like a root class. But here, this interface, root interface in a one-dimensional collections hierarchy. Hierarchy also I'll show you. This is just, it is a super interface. It is a just super interface for all one-dimensional collections. Using subclass reference or subinterface reference, super interface methods can access. Using subclass reference can access superclass methods. Like that, here it is top of the hierarchy. All one-dimensional collection interfaces can access these methods. But it is interface contains abstract methods. No need to implement by us because we have one more category, general purpose implementations, second category. In that implementations category, classes are there. With that classes, we can create object, we can call methods. Okay. Now, this is only theory. These 10 interfaces, you will learn only theory. Now, second one. Now, second one, list interface. List interface, note down. It is a root, it extends collection interface. It extends collection interface. It allows duplicate elements. It extends collection interface. It allows duplicate elements. See, which is superclass for all Java classes? Object class. Object class called as root class. Object class called as root class. Here it is root interface. At the top of the hierarchy, this interface will be there. That means remaining all sub interfaces. For example, here only, see what I given? It extends collection interface. List is a sub interface of collection interface. Using list class reference, list interface reference, can I call collection methods? Yes, that is root concept. Okay. It allows duplicate elements. Now, third one, set interface. It extends collection interface. It does not allow duplicate elements. It extends collection interface. It does not allow duplicate elements. See, this collection is a root interface. From that, list derived. From this collection only, set derived. Now, for list and set, which are common, that is available in collection. See, it is collection interface. It is list interface. It is set interface. Here, collection interface. Here, list interface. Here, set interface. See, list extends collection. Set extends collection. Here, list set. What is the difference? List allows duplicates. Set does not allow duplicates. For both common points, collection interface. Okay. It is a root interface for these two, which are common. Those are available here. Which are specific to list, available here. Which are specific to set, available here. So list derived from collection, set derived from collection. Collection methods can be accessed by list also, set also. Okay. It is root interface. Now, list set. Next, map interface. It is a root interface in a two-dimensional collections hierarchy. It is a root interface in a two-dimensional collections hierarchy. It is a root interface in a two-dimensional collections hierarchy. It is a root interface in a two-dimensional collections hierarchy. Say, map interface. It is a root interface in a two-dimensional collections hierarchy. Next, write it. Two-dimensional collections contain key value pair, key and value pairs. I'll explain. Two-dimensional collections contain key and value pairs. It does not allow duplicate keys. Values may be duplicated. Values may be duplicated. Values may be duplicated. Is it over? See. Now, set differences between set and map. Differences between set and map. Note down. Differences between set and map. One side set. One more side, map. Differences between set and map. One side set, one more side map. Set side. Set side. It is a one-dimensional collection. It is a one-dimensional collection. Here. It is a two-dimensional collection. Set. It is a one-dimensional collection. Map. It is a two-dimensional collection. It contains elements. It contains key and value pairs. It contains elements. It contains key and value pairs. Set is one-dimensional, map is two-dimensional. It is an index-based collection. It is key-based collection. It does not allow duplicate elements. It does not allow duplicate keys. Values may be duplicated. Values may be duplicated. Say example. Example. Here example. Suppose here numbers. Index 0, 1, 2, 3, 4. It is index. It is element. Here key value pair. Employee number, salary. Employee number, salary. differences between set and map. 4 differences are there. I'll explain. Just write it. Is it over? See, set and map differences. What I given, see, it is a one-dimensional collection. So one-dimensional. It is a two-dimensional collection. Here, employee numbers, salaries. Two-dimensional. It is only like example, student marks. Here, employee numbers and salaries. It is a one-dimensional. It is two-dimensional. That is first difference. Second difference, these are called elements. These are called elements. These are called key value pairs. It is one pair. It is one more pair. It is one more pair. Key value pair. Okay. Key and value pairs. It is like a one key and value. Key and value. Employee number always associated with salary. Employee number associated with another salary like this. It is index based collection. Suppose if you want to retrieve 55, you have to use 2. If you want to retrieve 23, you have to use 0. If you want to retrieve 24, you have to use 3. If you want to retrieve this salary, this number required, not index. No index here. Key is a main role. This value, if you want, this key you have to use. This value, if you want, this key you have to use. So, key if you pass, value comes. You can iterate, you can perform operations, everything with keys only. Key is a main role. Okay. Now, it does not allow duplicate element. Here, duplicate, if you write, error will not come. It will be ignored. So, 1000 elements are there. But what already is there also we cannot predict. If you enter one more, it is not error. It is ignored automatically. That is not added. That type written logic. So 1000 elements already present. If you enter one more, automatically it will check whether it is there or not. If it is there, it will not allow. Error will not come. It is not added. Okay. After adding 1001 also 1000 only shows. Duplicate if you write. Okay. Map. Keys duplicate not allowed. Values duplicate allowed. Suppose Gmail usernames, passwords are there. Gmail usernames and passwords. Username duplicate allowed or not allowed? Not allowed. Password allowed. Your password, other people password may be same. Okay. Password is allowed. Username is not allowed. Username is unique. Password is not unique. For example, ATM card number is there. That is duplicate is there. ATM card number. No duplicate. Unique. PIN number. Your PIN number, other people PIN number, thousands of people will be there. PIN number how many digits? 4 digits. Then a maximum how many? 9,999. But more than that cards are there, no? So your PIN number, other people PIN number, some thousands of people will be there. Same PIN number will be there. But with only PIN number, it is not validated. ATM card also validated, no? That is the reason possible. So ATM card number is unique. But PIN number is not unique. Same number, some thousands of people will be there. Like that, based on that, we have to select. Now, ATM card number, we have to select as a key or value. Key. PIN number, value. Okay. Gmail username, key. Password, values. Suppose you want to take only username. This set also you can use. Only usernames you record if you want to perform some operations. So today, how many people joined in Gmail? How many people signed? That is, you want to find out. Like that, only usernames also you can take. If username password mapping record, username password map also you can use. Like that, we have to select. Duplicates required means we have to go for list. Duplicates not required means we have to go for set. And the key value pair, if you want to maintain, map. Depends upon our application requirement, whether list record or set record or map record, we have to select. Okay. This is about key value pair. Now, next one, sorted set. Next one, sorted set. Fifth one, sorted set interface. Note down. A sorted set is a set. A sorted set is a set in which elements are sorted. A sorted set is a set in which elements are sorted. See, sorted set, you can call it as set, but all sets are not sorted sets. Sorted set is a set, but every set is not a sorted set. So if elements are sorted, that is, we can call it as sorted set interface. Okay, that is sorted set. Next, sorted map interface. Sorted map interface. A sorted map is a map in which key and value pairs are sorted based on keys. A sorted map is a map based on keys. A sorted map is a map in which key and value pairs are sorted based on keys. A sorted map is a map in which key and value pairs are sorted based on map. Suppose Gmail usernames, Gmail passwords. Gmail username is key or value? Key. Password is value. Gmail username, Gmail password as a pair, I'll maintain. Okay. After that, I want to sort. Which one you have to start? Based on which one you have to start? Username, keys, username. But while sorting, the associated password will be there. No, that is always that place only. Associated value. Suppose when key position changed, value position also should change. That pair compulsory should maintain. Otherwise, keys sorted, values sorted means your username, other people password. Other people username, your password. It will be happen, no? Keys are not sorted, password like that, not sorted. While sorting, keys only considered. While sorting, the key value pair as it is will be there. If key position changed, value position also changed. If not changed means many problems will occur. Okay, your username, other people password, other people username, your password, it will be happen. Key value pair always it maintains. Okay, that's what based on keys. Based on keys, keys only important, keys only considered. Seventh one, navigable set. Navigable set. It is used to navigate elements in a set. It is used to navigate elements in a set. Navigable map. It is used to navigate key and value pairs in a map. It is used to navigate key and value pairs in a map. It is used to navigate key and value pairs in a map. Index, key, value, and element. These are terminology. Otherwise, call it as items. General. Key and value pairs in a map. It is used to navigate key and value pairs in a map. It is nothing but, suppose these are elements. These are elements. Elements are available in set or list. Like this we have. Okay. Now, first of all, cursor is here. Okay. You will accept the, you will print this one, or you will perform some operation on this one. You will move the cursor here. Now again, you will accept this one. You will perform some operation. You will move the cursor. This is called navigation. This is called navigation. General word, iterating. Okay. General word, iterating, like that. Traversing. In a data structure, we are calling traversing. Here, iterating, navigating, like that we can call. That purpose, this is required. If two-dimensional collection is there, if you want to navigate, navigable map required. So this is one pair. This is one pair. This is one pair. You can move the cursor. First cursor here. You can move the cursor. Again, you can move the cursor. Again, you can move the cursor like this. That is called navigation. Navigable set, navigation, navigating elements. Navigable map, navigate key value pairs. But I'm not giving any program here. Reason, these are interfaces which contains abstract methods. No need to implement, already implemented in second category. It is only theory part. Programming, next part. Okay. Next, queue. Queue interface. It is called as first in, first out list. It is called as first in, first out list. FIFO. It is called as first in, first out list. It allows insertion at rear end and deletion at front end. I'll explain. It allows insertion at rear end and deletion at front end. Deck. Deck stands for double-ended queue. It allows both insertion and deletion at both the ends, front end and rear end. It allows both insertion and deletion at both the ends. Front end and rear end. It allows both insertion and deletion at both the ends, front end and rear end. Is it over? I'll show you the differences between queue and deck. Queue and deck I have to explain. With the diagram, I'll explain. So queue is a first in, first out list. Queue allows insertion at rear end, deletion front end. Deck, double-ended queue, allows insertion, deletion at both ends, front end, rear end. Now I'll show you. Note down differences between queue and deck. Differences between queue and deck. Queue and deck. First one. It is an implementation of queue data structure. It is an implementation of queue data structure. Here. It is an implementation of deck data structure. It is a first in, first out list. It is not a first in, first out list. It allows insertion at rear end only. It allows insertion at both ends. It allows deletion at front end only. It allows deletion at both ends. See, so this is called front end. This is called rear end. Front end, rear end. Insert, delete. insert. So inserting both side possible. Insert, insert, delete, delete. See, first note on this all. Over. See, this is Q. It is front end, it is rear end. Rear end inserting, front end deleting. It is deck, double-ended Q. Both sides inserting possible, both side deleting possible. Suppose like this element comes, one element stored here. Okay. One more element comes, that element stored here. One more element comes, one more element stored. One more comes, one more stored here. One more stored here. Now, if you want to delete, deleting 23 only possible. Without deleting 23, 45 not possible. Without deleting 23 and 45, 56 not possible. Even after deleting these all, again this side inserting not possible. Like that it supports, it is called Q. But any element deleting possible, any element inserting possible means there is no difference between array and Q. Array everything possible, no? So these are some data structures having some meaning already implemented. According to that only it works. According to that only works. Here predefined, but array means you are going to write the programs. But these also implemented with arrays only. That means inside array only will be there. That is the reason array style only appears. Now here, suppose I'll insert one element, I'll insert here 23, same 45. Suppose year 56, year 12, year 55. I inserted. Now here, if you want to delete, this 23 can be deleted, 55 can be deleted. But if you want to delete here, 23 only can be deleted. If you want to delete here, 23 can be deleted, 55 can be deleted. But after deleting also, again if you want to insert, possible. But here if you delete, inserting this way not possible. Again, element should come this way only. Okay. But it is not like a array. N number of elements add, accepted, accepted, accepted. So size is not required here. N number of elements, no limit. How it works? What is the logic? I'll explain. So internal logic written. What the written I'll explain. See, this element if it is deleted, in this location if you want to insert, not possible. These elements only should move. first in, first out. See, which element came first? 23 came first. 23 is going out first. But here, 55 can be deleted. 23 can be deleted. But even before deleting this one, other element also can be inserted. Possible. Other elements also can be inserted both the sides. Okay. So this type, if it is maintained, it is called queue. This type, if it is maintained, it is called deck, double-ended queue. These are predefined classes, interfaces, and implemented in some classes. Those classes contains methods. Like that only works. If any element can be deleted, any element can be inserted, means there is no difference between arrays and these all. Okay. So every data structure, one concept is there. According to that, it works. These 10 interfaces you have seen. That is only description you have seen. Only description. Programs you didn't see. Now, next. Write it. The hierarchy of one-dimensional collections. The hierarchy of one-dimensional collections. Collection inherited. Like list, set, queue. Set inherited, sorted set, queue inherited, and deck. Navigable set. Next, the hierarchy of two-dimensional collections. Map. Sorted map. Tree map. Sorry. Navigable map. Collection, list, set, queue, sorted set, navigable set, deck. 7 interfaces, one-dimensional. 3 interfaces, two-dimensional. Seven interfaces, one-dimensional. 3 interfaces, two-dimensional. Over. Now, by using deck interface reference, can I call queue methods? Yes. Can I call collection methods? Can I call set methods? No. Okay. Superclass, superclass, superclass like that up to root class. Okay. Or super interface up to root interface. But other classes methods you cannot access. Okay. Now, by using sorted map interface reference, can I access navigable map methods? No. Sub also not possible with super. Okay. Subclass object can I assign to superclass? That is upcasting. Superclass object can I assign to subclass? No. Downcasting. Superclass to subclass, down. Subclass to super, up. Up always valid. Down needs upcasting as well as explicit type conversion. That purpose only this hierarchies. Okay. Now, you studied java.util package. Java.util package classes and interfaces divided into how many categories? Two categories. What is first category? Collections framework collections. Second one, legacy collection. Collections framework collection means which version onwards? 1.2 onwards. 1.2 and above. Okay. Legacy collection means 1.0 and 1.1. That is legacy. Legacy nothing but old. Now, collections framework collections, how many subcategories divided? 3. What are those? Core collection interfaces, general purpose implementations, more utility collections. Core collection interfaces, 10 interfaces you studied. Okay. Now, next one, general purpose implementations. General purpose implementations. General purpose implementations. Write it. Core collection interfaces implementation classes are called general purpose implementations. So core collection interfaces implementation classes are called general purpose implementations. So the 10 interfaces, whatever you studied, those interfaces, implementation classes are called general purpose implementations. So 10 interfaces, implementation classes are called general purpose implementations. Okay. Now, array list, write clearly each word first letter capital. Linked list, has set, linked asset, tree set, hash map, linked hash map, tree map, priority queue, array deck. General purpose implementations. Core collection interfaces implementation classes are called general purpose implementations. Array list, linked list, hash set, linked asset, tree set, hash map, linked hash map, tree map, priority queue, array deck. General purpose implementations. or 10 classes are there. So in this category, 10 classes. In previous category, 10 interfaces. Now, I'll ask some questions, give me answer. With previous category knowledge, you can give answer. Even seeing the class names also, you can give answer. Possible. Okay. In 10 classes, how many list interface implementation classes are there? You can give answer possible. If you see the class names, you can give answer. How many? 2. What are those? Array list, linked list. How many set interface implementation classes are there? 3. What are those? Hash set, linked hash set, tree set. How many map implementation classes are there? 3. What are those? Hash map, linked hash map, tree map. How many queue implementation classes? 1. What is that? Priority queue. How many deck implementation classes? 1. What is that? See the class name only can give answer. No? List, set like that. Okay. So now, what is the difference between hash set and hash map? You can give answer possible. Hash set is 1-dimensional. Hash map is 2-dimensional. Next, hash set contains elements. Hash map contains key and value pairs. Hash set is index-based collection. Hash map is key-based collection. Hash set does not allow duplicate elements. Hash map does not allow duplicate keys. Values may be duplicated. See, I didn't teach, but with that first category knowledge, you are giving answer, no? This is only interrogation. These only interrogations. What's the difference between linked hash set and linked hash map? Same differences, no change. What's the difference between tree set and tree map? Same differences, no change. Tree set, tree map. Okay. Concept in a properly, if you understand, you can answer. That's it. So hash set, hash map, same differences. Linked hash set, linked hash map, same differences. Tree set, tree map, same differences. Okay. Priority queue and array deck. You studied, no? Queue and deck. Queue is first in, first out list. But here, little bit changed here. Priority queue based on priority works. That interface implemented, but little bit changes came here. It allows deletion front end, insertion rear end, deck both the ends, both the operation possible like that. Okay. Here now, what's the difference between array list, linked list? They'll ask. What's the difference between hash set, linked hash set, tree set? They'll ask. What's the difference between hash map, linked hash map, tree map? Also they'll ask. These all you have to learn, not completed. Okay. Now here, one by one, here you'll study. Here theory also, programming also. Now, first one, array list. Just array list, write it, enough. Here, it is an array representation of list implementation class. It is an array representation of list implementation class. It is an array representation of list implementation class. Just you observe, if you open documentation, here array list, say it is resizable, they'll give, say resizable array implementation of the list interface. It is also right answer. That is also right answer. Okay. Here constructors, methods, here capacity, size, these all required. Here you can also call it is a resizable. It is a resizable array of list implementation class. We can also call it is an implementation of linear list data structure. It is an array representation of list implementation class. It is a resizable array of list implementation class. It is an implementation of linear list data structure. All are right. There is no mistake. See, if we create array like this, how many elements you can store in this array? 5. Is it possible to store 6th element? Is it possible? No. Okay. Can we write any logic to add 6th element? Okay, it doesn't support actually. Okay, that is, I given size is 5. So 5 elements can be maintained. 5 elements can be stored. Can we write any logic to insert 6th element? But here, what I given, see, resizable array. That means you are already written logic. Otherwise, how it works? Now, in this array list class, it is a class, some logic already written. Now, with that logic, you enter 10 elements also, 20 also, 100 also, 1000 also accepted. It won't stop. N number of elements add. Resizable. It is resized automatically. Increase it. Increase it, decrease it, increase it, decrease it. If elements are added, increase it. Elements are removed, decrease it. Resizable, that is. Logic already written. So, what the written logic you observe? Whenever 6 elements comes, first 5 element they'll store. Whenever 6th element comes, what they'll do is one more array they'll create with 6 elements. These all elements, whatever is there, they'll copy here. The 5 elements, whatever already stored, they'll copy in this array. After copying, here new element you can add, no? After adding, they'll delete this. Now, this one will rename as a. What will happen? It appears like a added only, no? Actually, what we did, one more array created. Old array elements copied. New element added. That old array deleted. This array renamed. Then it appears like a 6th element added. Suppose when 7th element comes, now what they'll do again? Integer array b equal to new integer of 7. One more array they'll create. Then what they'll do? These 6 elements they'll copy into this array. Latest element they'll add 7th element. After that they'll delete this. This is they'll rename. See, it appears like adding one more element only, no? So this type of logic already written. That is the reason resizable array. Okay, it is resizable array of list implementation class. But what is the concept of list? Duplicate allowed. So next, write it. It allows duplicate elements. It allows duplicate elements because it implements list interface. It allows duplicate elements because it implements list interface. It allows null values also. Null also we can enter. Null also we can enter. It supports both homogeneous elements and heterogeneous elements. It supports both homogeneous elements and heterogeneous elements. Homogeneous means same type of elements. Heterogeneous means different data elements. So all integers also you can maintain. Mixed also you can maintain. So homogeneous, same type of elements. Heterogeneous, different type of elements. Same elements can be maintained. Different type of elements can be maintained. How it is possible? We will see in a programming. Same type of elements also allowed. Different type of elements also allowed. Okay. Now, see, I said resizable. But first initially 10 allocated. When 11 comes, that logic works. So initial capacity of array list is 10. Initial capacity of array list is 10. First 10 allocated. 10 allocated. After allocating 10, one first element comes, second element comes, third element, like that up to 10 accepted. When 11 comes, that logic. Okay. Here, that information available in everything in documentation part. See, it is array list. It is array list. See, it is java.util. This class is available in util package. What is this? You will understand in tomorrow class. That is tomorrow class. That Angular bracket diamond operator, tomorrow class. See, java.lang.object is superclass. From that class, abstract collection. From that class, abstract list. From that class, array list. So, array list to superclass is abstract list. Abstract list superclass is abstract collection. Abstract collection superclass is object. Here, all implemented interfaces, these many interfaces implemented in this class. Direct to known subclasses, this subclass, these three. Like that, library is very vast. That complete information will be there. Say resizable implementation of the list interface. Okay. So it allows including null. Say complete documentation will be there, but documentation, if you want to read, you should have more patience because very depth will be there. That is unnecessary depth, not required to you, because whatever required to get a job, that is you have to learn. But each and every point not required. No one can learn. See, it is a one class. See, still scroll bar is here only. Observe. See, this is one class. One class only like this. But like this, 4,000 classes are there in core Java. Okay. That is no need to learn complete. Important points for interview purpose. These all methods, the description in a programming you will see, you'll understand. Okay. This is, you'll understand further like lambda expression related concepts. See, 1.2 version released. It comes under, it is a member of Java collections framework. See, here constructor. See, constructs an empty list with initial capacity of 10. Constructs initial capacity of 10. Suppose if you use this constructor, you can specify how many you want to insert. Suppose initially 5 only required. You have to call this constructor. If you want 10, that one. By default 10. If you want 11, 12 like that, this one also. Here methods, adding, removing, so many methods are there. See how many are there? So many are there. Now, here what will be happen is initial capacity of array list is 10. 10 elements allocated. After filling 10 only 11. After filling, that is called load balance, like load factor. Load factor of array list is 100%. Load factor of array list is 100%. Load factor nothing but if 10 elements memory allocated, 11th element memory, when it will allocate? After filling 100%. That is called load factor. But some collections, what will happen? 75% if it is filled, then only new elements memory allocated. Why? The technique, if you understand, hashing technique, if you understand, then you'll understand. That in further sessions. That hashing, when it comes, this third one. After array list, linked list, then hash set, then you'll understand. This load factor is 75% will be there. Why load factor is 75? You'll understand while learning this technique. What is hashing? I would explain. Okay. These all points required. Interview, what they'll ask you, these only. Will it allow duplicate or not? They'll ask. Will it allow null value or not? Will it allow homogeneous or not? Will it allow heterogeneous or not? What is the load balance, load factor? What is the initial capacity? This type questions only, written test interview questions. Okay, these all points you have to remember. Writing program is very simple, but so many points are there. Those all you have to remember. Every collection, these all required. What is array list and which data structure implemented, and will it allow duplicate or not? Will it allow null value or not? Which is homogeneous or heterogeneous, and initial capacity, load factor. These 5-6 concepts are there. No, for every collection it will be different. That is you have to remember. Okay. This continuation we'll see tomorrow. Tomorrow program. This array list program. Okay. Tomorrow not coding will be there. Coding. This collections coding. Okay. Collections coding very simple. Nothing. As compared to Java stream serialization, these all, it is very simple. Adding, removing will be there. That's it. We'll see tomorrow. Any doubts are there, online students? Any doubts are there? Next, okay, 1 minute, 1 minute. Your doubts I'll clarify. What is load factor? Load factor is 100%. If 100% is filled, then only stored. Scanner class in after 3-4 days, it will come. Release second point, resizable. Resizable means it will increase, decrease. First page collection list I removed. Scanner class in further session it comes. More utility collections list scanner class. Any other doubts? We'll see continuation tomorrow.